Hello, welcome to In 5 Minutes. Next circuit is again a clamper circuit. What changes you will find in the clamper circuit is the position of the diode and the voltages which are connected in series with the diode. Now in this diagram, when you look at the position of the diode and the input signal, what we need to find is when the diode is getting forward bias. That is our step 1. We need to find the cycle in which the diode is getting forward bias. When you look at the diagram, in the positive half cycle, plus minus, diode is positive, negative. So positive is connected to the positive. So in the positive half cycle, the diode is getting forward bias. So we have start our analysis with the first positive half cycle. In the first positive half cycle, when you apply KVL in the input loop, which starts from this point and goes till this point. So when you apply KVL, the equation will be VI. Then the polarity of the capacitor will be plus minus because the capacitor now is getting charged in the positive half cycle. So VI minus VC minus 2, that is this biasing voltage 2 volts, equals to 0. Now our VI in this case, we have plus 5 in the positive half cycle. So 5 minus VC minus 2 equals to 0. So VC comes to 3 volts. That means the charge buildup on the capacitor in the positive half cycle is 3 volts. Now there is something called as RC time constant. RC time constant makes the charging and discharging of the capacitor. The charging and discharging of the capacitor is dependent on the RC time constant. The value in the clamper circuit is kept as very high. Because of very high value of RC time constant, it doesn't allow the capacitor to discharge much. So it stores the charge when the diode is open circuited. That is the basic fundamental of the clamper circuit. When diode is open circuited, it will hold on the charge rather than discharging, which is the basic characteristics of the capacitor, that it will store the charge, it will get charged and it will get discharged. So because of very high value of RC time constant, it stores the value when the diode is open circuit. Yet the charging on the capacitor is 3 volts in the positive half cycle. Similarly, we can find the output. Since the diode is short circuited, the circuit in the positive half cycle will be, you will have capacitor, the diode is shorted, then you have 2 volts connected here and you have VO plus minus VO plus minus 2 volts. So when you apply KVL over here, you will have VO minus 2 volts equals to 0. So you will get the output voltage as 2 volt in the first positive half cycle when the diode is short circuited. This is the first step. Now coming to the next half cycle, that is the negative half cycle. What will happen in the negative half cycle? That is our step 2. Negative half cycle, the diode will be open circuited. Why? We will provide negative sign over here, positive sign here. That is the input voltage will have the reverse polarity as it was in the positive half cycle, and the charge on the capacitor is positive, negative, and the value of the charging of the capacitor is 3 volts. Now the circuit when we are in the negative half cycle will look like, you will have capacitor, this will be open circuited, you have 2 volts which will become redundant because of this open circuit. Then you have R across which we are finding the output voltage VO, which is plus minus VO R, this is 2 volts. Now since negative half cycle, you have minus plus charge on the capacitor VC, which is 3 volts, capacitor is as positive negative, you have VI. When you apply KVL, from which point to which point? From this point till the output voltage, because we want to find the output voltage in the next half cycle. So the equation when you apply KVL will be KVL from, we are applying from input side to output side. So what will be the equation? VI minus VC minus VO equals to 0. Now VI in this case is minus 5, VC is minus 3, which is equals to VO. So you'll get VO as minus 8 volts in the negative half cycle. So we got in the positive half cycle, we are getting output voltage as, how much we have got? 2 volts, and negative half cycle we are getting the output as minus 8 volts. How much is the peak to peak swing? So when you draw the waveform, look at the waveform, you have 2 volts and minus 8 volts. That is the total peak to peak value again remains the same, right? And input is again 10 volts peak to peak, output is 10 volts peak to peak. This is how we solve the example of the clamper.